Okay guys, today we're going to talk about graphing data, particularly this process is called linearization, and we're going to do it with most of the labs we do this year, and typically there's one free response lab question that has you do it on the AP exam. So the whole idea behind graphing data and linearization is that you take your data, take several trials, and you figure out a way to graph it that gives you a straight line, and you end up either using the slope of that line or the y-intercept of that line to find some kind of important value. And so for the example we're going to use today, we're going to talk about circles. And let's say that we take a bunch of different circular objects, large ones, small ones, and for each one we measure the radius of the circular object, and we also measure its circumference. So let's say that our first object is a small circle and has a radius of 2.15 centimeters. And then let's say we measure the circumference of that object, and the circumference of that object is 13.1 centimeters. And then let's say that our next object is a little bit larger, a lot larger. Let's say it has a radius of 10.07 centimeters. And then we measure its circumference, and for that one we come out with 65.5 centimeters. Let's say our third object's kind of medium. Let's say it has a radius of 6.02 centimeters. And when we measure its circumference, the circumference comes out to 37.0 centimeters. And then let's say we take one final object, and it's the biggest of all, and let's say that it's a radius of 15.21 centimeters. And then we also measure its circumference. And the circumference of that object ends up being 100.4 centimeters. Alright, and so let's say that the whole purpose of this lab is to figure out an experimental value of pi. And so what we're going to do now is we're going to figure out what is our relevant equation. What is the equation that relates our two pieces of data? And of course, hopefully you all know that the circumference of a circle should equal 2 pi times the radius. Okay? And so then what we're going to do is we're going to compare that equation to our y-intercept equation that you've learned in math, which is that y equals mx plus b. Okay, so there's a couple of options for the way we could graph it. One thing we could do is we could put the circumference on the y-axis. We could put the radius on the x-axis. And if we do that, what we can see is that we should end up having a slope that's equal to 2 pi and a y-intercept, in theory, should equal 0. So, if we put the circumference on y, and we put the radius on the x, we should get a slope that equals 2 pi and a y-intercept that should equal 0. Okay, so now I'm ready to make my graph, and the first thing I'm going to do is put the title up top and label both axes. So the first thing I've done is put my title up top, and you'll notice that I've put the value I'm graphing on my y-axis versus the value I'm graphing on my x-axis. And now I'll label both axes with both the title and the units they're measured in. So next I need to put an appropriate scale on my axes, and the way you want to do that is preferably start both of them at 0 unless it's a really weird circumstance. Evenly space your scales up to a largest number that's slightly larger than the biggest number that you plan to graph. You do need to make sure both axes are evenly spaced with no breaks, but the two axes can be scaled differently, which is what I'll do here. So for my circumference axis, my y-axis, I need to go up to 100.4, so I'm going to make sure I have an evenly spaced axis that goes from 0 up to a little more than 100. And since my largest radius was just a little over 15 centimeters, I can evenly space it up to maybe 20. Okay, now that I have a title, have my axes labeled, my axes scaled, I'm ready to plot all my points. So I'm going to go ahead and do that. Okay, so now that we've plotted all our points, now we need to make what we call our best fit line, or our line of best fit. So we are not connecting the dots. What we're going to try to do is make one straight line that goes as close to as many points as possible. And if it doesn't actually hit all the points, and you're going to have some points above and below the line, you want to try to have about half of them above and half of them below. So if you're doing this on paper, you would actually take a ruler and line it up the best as possible, and then use your pen to follow the ruler. I'm going to do the best I can here with my line tool, so we'll see how this goes. Okay, so that looks pretty good there. Alright, so the next thing we want to do is we want to calculate the slope of our line. And to calculate the slope of our line, we're going to pick 2 points on the line, and they should not be data points. So I'm going to pick this point right here, and I'm going to pick this point right here, and I'm going to use those points to calculate the slope. Okay, so it looks like my first point here is right around 424. And it looks like my second point here is right around 1384. And I apologize, this first point looked a little over 25 to me. That would be 26, not 24. Alright, so now we said earlier that the slope is equal to 2 pi, and of course the slope is going to be the rise, 84 minus 26, divided by the run, 13 minus 4, and so that's going to be 58 divided by 9, which comes out to 6.44. Okay, so then pi is going to equal 6.44 over 2, which comes out to 3.22. So not perfect, but a pretty good result. And that's how we can use linearization of data to figure out an important value using a graph.